I welcome you to the second session on the data analysis and database design today. In the previous session, I spoke about the concepts of databases, keys like primary keys, foreign key, candidate key, etc. Then I introduced you to the definition of database management system. Objectives of database management system have been discussed, and merits and demerits of the database management systems have been discussed, and I also spoke about the visual tools. In today's session, I will be speaking about forms, macros, query languages. In this, I will be covering about the structured query language and query by example. The most important theory of database design is normalization theory. I shall be discussing about that also today. And apart from this, designing a logical database, converting the same to a physical database will also be discussed. So I shall start the session with forms. See, forms are the most important component of any commercial relational database management system. In the world database management systems, whenever you have to design a form, you need to do it by your own using the tools that are available in the databases. Maybe you have to use some graphic libraries, you have to write some code to design a form, and you have to do a lot of work from your side. But in the RDBMS like Oracle and other advanced RDBMS systems, you are having a package specifically designed for you to design forms. And designing forms is must in almost each and every application. For example, you think about the student admission system application. In that, you need to fill up an application form, you need to submit it, then you need to be filling up the change of study center addresses, change of telelearning center, change of your address. For each and everything you need to fill up a form, and the existence of such forms in your database application packages is very much important to make you work easily and make things easy. The Oracle has provided a forms package with the help of which you will be designing the forms. Whenever you design a form, you will be associating that particular form with the fields in a table, and in the form the fields will be directly mapped onto the fields of one or more tables. It is not necessary that one single form will be directly mapped to one table. For example, one form may be mapped to 5 or 6 tables. It means that a subset of fields of that particular table as well as tables are extracted and displayed in the form. At the same time, you can also insert data using the forms. Let us say you have designed a form containing name, address, program. Now this name, address, program may be the fields of some table and enrollment number, which might be a primary key. So when you give your database application package to your customer, then when the customer starts entering, he will be totally invisible about the connection between the form and the table. What he sees is a form requesting him to fill up the fields, and he will start filling the fields, enrollment number, name, address and program, and he will be submitting it. Once he submits, all the data he has entered will be recorded in the table. So here there is no need for you to give a message that enter your enrollment number, again enter your name, enter your address, all these things. They all are displayed at a time in the form, and it is almost one-to-one correspondence between a form being filled on the paper and a form being filled on the computer. And the most important part is how to validate the data. Now suppose that you entered an enrollment number which is not at all existent in the database of IGNOU, then immediately there will be an error message. The error message might be in a different manner, like it is not similar to the errors that are showed when you compile your program in C language or C++ language, wherein the execution will be interrupted and a list of errors will be showed, and you start rectifying each error and then you start executing each one. See, here the paradigm is totally different. Whenever you enter data, that particular data is validated immediately, and you will not be allowed to go to the next field unless you change it. This message can be given by changing the color of the field. Let us say the fields are colored in green, and you enter some enrollment number which is invalid. Immediately that will start flashing in red color. It means that there is some error, you have to immediately change it. Only after you enter the proper data, it will be entered into the table and you will be getting a confirmation regarding the same. The programs that will be used to validate the data that is entered in a form are called triggers. Triggers are common feature of Oracle as well as other relational database management systems, and you should be well equipped with all the types of triggers that are supported by an RDBMS when designing forms. When you design forms, basically what happens is you will be doing your entire work with the help of triggers, and the code in C interface or C++ interface will be minimal. You will be using macros in PL by SQL, you will be using SQL statements to do the updations, you will be using triggers to validate the data, and the code like 1000 lines or 500 lines, this concept is totally disappearing. When someone asks you how many lines of code is there in your project, you might be saying that there is no code at all and they are full of 100 or 150 forms. This is the significance of forms in any relational database management system as well as any application which is having database backend. The next topic is reports. As you know, whenever you are requested to prepare a report, you need to collect the data from all your tables and then you need to show it on the report. So the same is also provided in the RDBMS, and using reports you can present data in a printed format. You can have data that can be accessed from both tables as well as queries. You can have multiple reports that can be combined to produce a complex one. So here let us think about the correspondence between the tool that is used to make reports in RDBMS softwares and making a report manually. When you are making a report manually, you have to go through a lot of files, paper based, and then you will be collecting all the data. Then you will be putting it on another sheet, again you will be going through it, and then you will be finalizing your report, and again you will be entering it in Microsoft Word or something like that, take a printout and submit it. But whenever you need a report, you need to do the entire exercise, and the time consumption for making these reports is going to be very high whenever you are doing it manually. To ease the task, the relational database management systems are also providing automatic tools along with their packages. These packages will be used to make the reports. For example, Oracle will be having its own tool for making reports. So whenever you are creating a report, it will be asking you to enter the fields from which the data has to be inserted into the report. This data is again from the tables. They are nothing but they are the fields in tables. So you need to enter the fields in the tables whose data is to be recorded in the reports. And this data need not be necessarily corresponding that if you have a one report, it is directly corresponding to one table. Again, you can have two tables from which the fields are grabbed and they are placed on the single report. You might be 100 tables. It means that you can make any complex report which needs information from multiple tables with the help of just one report. You also have the facility to again make reports from the reports. So suppose that you created two separate reports from 6 or 7 tables, and now you need to make another report which will be using information which is present in the two reports. You can do this. So it is not essential that whatever data is present inside the report is obtained directly from the tables. It can also be directly from the reports. Now let us speak about the macros. Now macros are nothing but they are very small procedures. These procedures are used to execute whenever there is a need. For example, usually a macro will be containing a very few number of lines of code when compared to a procedure. A procedure will be containing a lot of lines of code, but a macro will be containing a very few lines of code. In the case of procedure, what happens is whenever you make a call to the procedure in your program, the control will be transferred to the procedure, then the code in the procedure is executed. At the end of the code, the control is again transferred to the program. But this is not the case with the macros. In the case of macros, what happens is whenever you make a call, the code corresponding to that procedure is inserted at that call. So let us say you have 5 lines x1, x2, x3, x4, and after x4 you have a call to some y, and then you have x5. So after this x1 to x4 lines are executed, whenever there is a call to y, the control is not transferred, but the code inside the procedure y is embedded in the place of y, and the execution will continue. It means that the length of the code will be increasing whenever there is a call to the procedure. Wherever such possibilities are there that you have 2 or 3 lines of code in a procedure and you are calling it at a number of places in your program, you need to write a macro. And these macros are normal feature of any RDBMS based application. You can have PL by SQL procedures, which are nothing but there are other forms of macros which will be executed whenever there is a problem or whenever data is entered, depending on the application. So in databases, mostly whenever you are using the tools provided by the RDBMS like forms and reports, you will be automatically using macros because the code is minimal. Whenever the code is less, you have to use macros. Whenever the code is large, you have to use procedures. In the case of procedures, the overhead is that there is a transfer of control from the program to the procedure. This consumes some time. To avoid this time, you are having macros. In the case of macros, the code is embedded. It means that the length of the program is increased. It means that more memory is needed to store the program. So you need to do all this analysis before deciding whether you need to have a macro or a procedure. Suppose that your application is not time critical, it is not a real time system, then you can go for procedures. Suppose that you have a memory problem, that you are running short of memory and there are chances that the database updations and database selections may take some more memory. In such case, you better use macros and you don't go to the procedures. And let us see how to create a database. Creating database. Every database management system has the capability to create databases, tables in which the 3 entities have to be entered: field, name, type and size. DBMS thereafter allows entry of data in which all records have the same structure. Now, whenever there is any relational database management system, it is compulsory that you create database. These commands that are used to create databases come under the data definition language statements. We already discussed about data definition language in our previous session. So creation of a database is must in any RDBMS package. Of course, that is very obvious, and you are having different commands in different RDBMS softwares. For example, in Oracle you will be using create command. Using that you will be creating a database. Creating a database is nothing but creating a set of tables. A set of tables will be forming a database. It is not necessarily that a single table is called a single database. It depends on the application. Suppose that you have one table on which your application is entirely based and you don't have any other table, then we can call that single table as your database. Suppose that you are having 5 or 6 tables in your application, then collectively they are called database. It's not that each table is a database. And you need to create a database, and when creating you also need to decide about the primary key, candidate keys, secondary keys and other things, because every RDBMS provides an option to the user to have a primary key. Once you decide that some field is a primary key, it will never allow the user to enter a duplicate field containing the same value. This is going to be a very big advantage whenever you put queries on that particular table, or whenever you are indexing the table for preparing different reports or browsing different data. So it is very essential that initially you make a database design. You should decide what all fields will be there in each table, then what are the primary keys, what are the secondary keys, what are the foreign keys. You need to analyze and design all these things, and only then find out what are the commands that have to be used to create a table in any relational database management system, and use the appropriate commands to create the database. Whenever I say create the database, it doesn't mean that you are creating all the tables with a single command. You are creating each table one after another using separate create commands. So in this way, first of all you are creating all the tables, then comes entering the data, then comes developing the programs which will be obtaining data, updating the data, as well as deleting and inserting the data. So the first step in any database application is database design. And there were different data types that you can give to your fields. Let us go through some common data types. Some common most common data types are character, text, date, number, integer, float, byte, long integer, memo, boolean, yes or no. Now all these are common data types. Each data field is having its own width depending on the RDBMS. Usually character is of 1 byte which contains 8 bits. Whenever you speak of text, there are several options, whether the RDBMS supports direct string data types or that you need to have a number of characters declared to make a string. Then you have a date field automatically, and whenever you are thinking of date field, basically it is supported in different formats. It can be US format, it can be India format, it can be any country's format, and all those options are provided whenever you choose a date field for your table. And you have to clear it whenever you create the field. Suppose that you choose US format, then it will be asking for the month first and then date and then year. If you are choosing some other format, it might be asking you the day first, then month and then year. You are having a different varieties of formats and you need to choose the appropriate one. Then comes numeric formats: number, integer, float, byte and long int. Byte is the data type which holds the least memory. Byte means exactly 8 bits, not more than that. Then comes integer, which can be 4 bytes or maybe varying depending on the RDBMS. Then comes a number, then float, which will be occupying 8 bytes, and then long integer, which will be occupying 8 bytes. At the same time, you need to go through the manuals that you have got along with your RDBMS software to find out the exact memory requirements of each of your data types. And then comes memo. See, memo field is nothing but you will be having a lot of notes in your field. Whenever you have a lot of notes in your field, you will be using a memo field. And then at last comes boolean field. Here we have written yes or no. It can be true or false. It can be 0 or 1, just like in C language and C++ language. It can be true or false in the case of Pascal. It depending on the RDBMS you use and the programming language interface you use, you will be having the boolean data type. So these are the most common data types that are available in any RDBMS system, and most probably you will be using only these data types in your tables also. Now let us go to how to define the data types. Whatever you are seeing on the screen is an Microsoft Access table. After you create a table, it looks like this. Initially there is a serial number which is of a number data type. Then you have nearly 7 fields from title to city, which all are text based, and then you have a pin which is again a number. Then you have state which is text, then you have email and other details. Now every field is having some essential data types, for example, your database might be containing some primary key, and then you might be having some text database, or then you can have a number data field, etc. But it is not possible that you can create a table having some data type which is not specified. Whenever you have such problems, you need to write your program in such a way that it will be using only those data types that are supported by the RDBMS. It is essential that every field has the following: one is name, the other is data type, the third is size. In some cases might be there is no need for you to give the size, but it is always preferable that size is input so that the structure and memory requirements can be taken care of whenever you update your database. And now I shall speak about the data models. Data models is very important concept. Data modeling techniques are present. There are several types of data modeling techniques, and here we will be discussing the entity relationship modeling. You have already studied entity relationship modeling in your first trimester, but then here whatever you are studying, it is an extension to that, but still we will be once again telling you all the concepts of what you have gone through your first trimester's data modeling. So let us start with data models. Whenever you are implementing a database design, there are two types of models. They are record based logical models, the other is object based logical model. In the case of record based logical model, you are having a hierarchical database model which uses a tree like structure. Then you have a network database model which uses a complex web like network structure, and then you have a relational database model which uses two-dimensional table structure. So here among all the three, the third one is very important, and that is the model which is widely used, the relational database model. That is why we call all the database softwares which use these models as relational database management systems. Here it uses two-dimensional table structure. In the case of object based logical models, you are having an entity relationship model, you have a binary model, you have a infological model, you have a semantic model. But the most important thing is the entity relationship model. Though you are speaking in terms of objects and relationships, ultimately you will be mapping them to a relational database management system. Though ER model is an object based logical model, it is converted to a record based logical model after you do the analysis. So how to proceed about designing a database using entity relationship model? This is what we will be looking in the coming up slides. Entity relationship model. In this table, our relation is represented by rectangle, relationships by diamonds or rhombus, and attributes by ellipses. So whenever you are designing a database, you need to first of all think about the real life objects that are existing. You should never think about a vague things like without thinking about normalization theory, just getting the data, making a table and making some keys as primary keys without finding maybe there is some duplication in future. All these things should be avoided to design a concrete database structure. So whenever you are going for a concrete database structure, you need to start with some data modeling technique. So you are requested to start with entity relationship modeling. This is the most widely used technique. Using this, you can create the tables, the structures of the tables, you can decide on the primary keys, you can decide on those tables which you never assumed that they will be existing in your database. All these things are needed to see that the queries are executed very fast and the user gets what he needs on the screen in the click of a mouse. Whenever you are designing a table, before designing the database, I said that you have to use some ER model. Whenever you are using ER model, you directly map the situation to your software. Just think about a payroll processing system. Whenever you are thinking about a payroll processing system, the first thing that has to come to your mind is the information of an employee. Whenever you think about the information of an employee, you need to immediately create an object of employee. So it is an entity. Whenever you create this entity, then think about the features of that entity. You can do this by following some English grammar, like what is the subject in your sentence. Here employee is the subject. So this employee will be the object. So all subjects are mapped onto the objects. Once you decide the object, then think about the features. Whenever you say employee, what are his features? Some designation, salary, duties, when he joined, his personal details, how much more service is there, all those things. And after having all this information recorded, you need to have all these features listed along with the object. To list all these features, you will be using an ellipse figure. So you will be using a rectangle figure to indicate an object. So employee is placed in a rectangle. All the features of employee are placed in ellipses. After placing this one, you will be getting some other thing in the same database design, another object. I mean, for example, your finance department. Whenever you think about your finance department, again the subject is department. Then again you have to think about the staff requirement there, what are the different sections there, what are the employees designations which will be mapped onto each section, all these things will be coming. So again you will be having an object department, again all its features like number of sections, mapping of the allocation of employees to a particular section, all these things. So in essence what I have to say is you will be having two different objects, one is employee, the other is department, indicate their features in ellipses and then find out the relation between them. Now the relationship is nothing but making salary statements. This is the relationship. So this relationship has to be indicated in a diamond. So you have three things here. One is rectangle where objects are indicated. The other is ellipses where features are indicated. And then finally comes diamonds where relationships are indicated. Whenever you make such a design, usually the first design will not be final. You need to do a lot of work seeing that there is no redundancy, there is no clash of information, there are no problems with updations, and your database design should always be in such a way that there is no repetition of information. That is why you use a database design. Once you are sure that this design is final, then map all these information onto the tables. For example, you have an object employee, so there will be a table called employee. It is a direct mapping. Once you have a table employee, what are its fields? The fields are nothing but the features of the employee object. So is name, salary, designation, all these become fields. And then the same is done in the case of department also. We shall be doing that with the help of a figure. Now how do you approach to a logical database design? The approach is, it can be a top-down approach, it can be a bottom-up approach. Top-down approach is thinking about what all objects are involved in your table and then starting the analysis and design technique from there, making the tables and then creating indexes, creating relationships and then writing queries and then writing programs and then giving the output. But in the case of bottom-up approach, it is totally different. Let me give an example of a bottom-up approach. Suppose that you are creating a library information system. Here you can start analysis in two different ways. You start directly designing the tables by using some data modeling technique. That is top-down approach. The bottom-up approach is totally different. In this case, what you do is, what are the frequent queries that are encountered by the staff of library? You can have an interview with the librarian who will be giving a list of all queries that he will be getting every day. You have to write down all the queries and then find out what is the information that has to be present inside the table. And from the queries, you also know that what is that information that have to be changed inside the database, what is the information that have to be output, how frequent are the queries on a particular table. So you are getting all information at the bottom level. Once you get this information, then start grouping all the fields into tables depending on the frequency of the necessity. And after that, you can see, whenever you are creating tables on the basis of the queries, there is no need for you to create the indexes. The reason is you are directly designing database as needed by the queries. Suppose that you are going on a top-down approach, you need to create the tables first, and then depending on the queries and the need, after going through your log analysis file of your RDBMS, you have to create indexes. But here you need not create indexes, but then the database design might be a little bit against the normalization theory. You might be grouping two fields in a table which are basically connected with two different objects. So rather than creating a relationship field, you are directly creating a table containing fields from two different tables. So now it is up to you whether you will be going for a bottom-up approach or a top-down approach. Where there is a need for maintaining your database application depending on the queries of the customers constantly, you need to go for a bottom-up approach. Better you start with the queries. Where there is a fixed output, like the user interaction with the database is just only print but not things like updation and other things, then you need to go for a top-down approach. So study your application first and then decide whether you have to go for a top-down approach or a bottom-up approach. So let me just take an example for you to see how an entity relationship model looks like when you apply it for a problem. So please go through this slide carefully, one after another. So here the heading is attributes, and here I am having an object called employee. The fields of the employee are E, it is nothing but his identity number, just like you will be giving some enrollment number as a student. The same is the case of any employee. He will be given some number on his identity card. This is going to be unique. Means no single number is given to more than one employee. So an employee will always be referred using that number. Then comes his name, the department where he is placed, his address, his date of birth, and the joining date. So here the object is employee and all the features are E, name, department, address, date of birth, and joining date. So just have a look at how did I specify them in an entity relationship model. The object employee has been indicated in a rectangle. The features are indicated in ellipses. So this is a single object. This is how the attributes of an object are indicated in an entity relationship model. Now whenever you are having multiple objects, you will be having relationships. The relationships might be varying. They can be in one-to-one relationship, it can be one-to-many relationship, many-to-one, and many-to-many. So the relationship is categorized depending on whether it is any of these four. And again for each of these four, you have four different symbolic techniques in ER model. So whenever you are indicating two objects, after making their attributes, whenever you are connecting them, you need to indicate whether there is a one-to-one relationship or one-to-many or many-to-one or many-to-many relationship between the two objects. Just have a look at this slide. Here this is a one-to-one relationship. Here you have two objects. One is employee, the other is employee number. The relationship has been indicated in the diamond, that is has. See, this relationship which is labeled has can be anything depending on the convenience, so that your system analyst or anyone who is monitoring your work can understand. Every employee is having one employee number, and one employee number is always assigned to only one employee. So here it is one-to-one from either way. That is why we have placed it in one-to-one relationship. Whenever you are speaking about one-to-one relationship, you will be indicating it as indicated here. Next comes one-to-many. Here you are having two objects. One is object titled boss, the other is object titled subordinates. A boss is having a lot of subordinates, and in a hierarchical organization, one person is placed usually under another person, and no one person will be answerable to more than one person, because you are always passing through the hierarchy. Under such circumstances, each boss is having many subordinates. So this is a one-to-many relationship. The most important point in this slide is the symbolic indication in the form of a tree-like structure on the right of the screen. You have to indicate your one-to-many relationships using this. Only for the demonstration purpose, I indicated it as one and many. Whenever you are making design documents after you enter some organization, you will be directly using the symbol but not any word. So this is an example for one-to-many relationship. Now comes many-to-many. In many-to-many relationship, I have taken two objects, namely programmer and project. One programmer might be doing more than one project, and each project is having a lot of programmers. So here the relationship is one-to-many from both the sides. Since it is one-to-many from both the sides, it has become many-to-many. So here the programmer is having more than one project in hand, and one project is assigned to more than one programmer. When you have relationships like this, we will be calling them many-to-many relationships, and you will be indicating by the symbol as indicated in the slide on both sides of the objects. That is the symbol for indicating a many-to-many relationship. Now let us go through the entire paradigm of the logical to physical design. Whenever you are making the design, whenever you are using some data model, you are making a logical design. The logical design will be containing only the relationships and the objects, and then you will be having attributes, all these indicated in diamonds, rectangles and ellipses. Once you make your design final, you will be going for the physical conversion and you will be directly mapping them onto the tables inside the table. So the step 1 is programmer has project. This is first logical step. Here you have identified the main entities programmer and project and the relationships particularly has. So the step 1 is only finding out objects. You are not thinking about the features of the objects. There you are only thinking about the relationship between the objects. So the project and a programmer. Then there is a relationship, a many to many. That is what you are interested in your step 1. In the second step, you will be finding out the features of each of these objects. So here in this you are having the programmer object and then project object, then a relationship has between these two objects. The programmer object is having name, employee number, date of birth, address, joining date as the attributes of the programmer. Then you have name, deadline, cost, software, hardware. This is the set of attributes for the object project. So basically here you are doing a blow up of the entities so that they contain all the required attributes. So in this step you will be first finding all the attributes and you will be listing them. You should be very careful during the step. Once it is crossed, there is no way for you to include more attributes. Whenever you are increasing the number of attributes, what is happening is you are basically increasing the structure of the database. Once you are increasing the structure of the database, its memory requirements will increase or decrease, and that is going to create problems whenever there are queries. There might be some garbage as output. So the first is find out objects, find out relationships. In the second step, you find out the attributes and then you indicate them in your data modeling technique. Here it is entity relationship model. Now let us go to the step 3. This is the most important step wherein you are converting from logical to physical. Here the programmer object is the title of one table. The project object is nothing but it is the title of another table. All the attributes listed for the programmer object are shown as the fields in the programmer table, and all the attributes that have been listed for the project object are shown as the fields of the project table. And here employee number is the primary key. Whenever you are indicating a primary key, you can indicate with some double ellipse or double loop in your entity relationship model. So here you are forming the attributes into fields and entities into the tables. So your object is mapped onto the table, your attributes are mapped onto the fields. The step 4 is creating the relationship set. Now whenever you are creating a database design, there what you are doing is you are finding out objects, you are finding out the relationships, and then you are finding out attributes, then you are making a mapping of your objects onto the tables. After creating tables based on the objects you have, you should think about the relationships. The relationship is nothing but it is also a table. Whenever you are having two objects with different set of fields, then there is a need for you to connect these tables. The only way to connect multiple tables, that is more than one, is using the relationship table. Here you have table work. The table work is nothing but it has come as a relationship between the programmer and project. So for work again you will be having a separate table. Whenever you are creating a separate table for a relationship, what happens is you will be grabbing the fields from your objects, main objects. Programmer is an object, project is an object, work is a relationship. Previously you have two tables, One is programmer, the other is project. But now you have three tables: programmer, project and work. Then what will be the attribute set of work? The attribute set of work is normally all the primary keys of programmer as well as project. So if employee number is a primary key of the programmer object, then that employee number will also become the field of your work. The same is the case with the project. Whatever is the primary key in the project object, that will be the member of the work table. So in this way, relationship tables are constructed. Now let me go through some terms associated with entity relationship design. Generalization. It is the union of many low-level entities in order to produce a high-level entity while suppressing or ignoring differences. So this is a bottom-up design. Here you are starting with several low-level entities and then you are going to a high-level entity. So you will be having subtables first and then you will be having the main table next. Then comes specialization. It is the reverse process of generalization, wherein additional specific information is introduced at lower level. This is a top-down design. Then comes aggregation. Aggregation is the process of compiling or adding information on an object, thereby abstracting a higher level object. So whatever information is there related to an object, of course the information, whenever I speak about the information, it is nothing but the set of attributes, thereby abstracting a higher level object. So whenever I am speaking abstracting a higher level object means you are having some other object which includes your latestly added fields. So the number of fields in your object are going to increase whenever you apply the process of aggregation. So once again, let me read what is meant by aggregation. It is the process of compiling or adding information on an object, thereby abstracting a higher level object. Now let me speak about the relational database management systems. Let us briefly go through the history of relational database management systems. The relational model is first described by Dr. E.F. Code in 1970. In the relational model, all the data is represented as simple row-column tables of data values. This is the most popular model available among all the database models. Basically, Dr. E.F. Code has given some set of rules. So if something has to be satisfied that it is a relational database management system, that software has to satisfy all the rules given by the code. Only then it will be qualifying as an RDBMS. For example, you have a DBase and then you have Oracle. Can I call DBase as an RDBMS? No. The reason is it doesn't satisfy all the rules of the code. In the case of Oracle, it satisfies most of them. That is why Oracle is termed as a relational database management system but not DBase. Properties of a relation or table. A table is perceived as a two-dimensional structure composed of rows and columns. Each column has a distinctive name, that is attribute name, whose order is immaterial. Each row represents a single data entity within the entity set. Each row-column intersection represents a single data value. Each row carries information describing one entity occurrence. Now let me elaborate on each and every of these points. As you know, the table is a two-dimensional structure and then each column is having a distinctive name. The most important point is that the order of the columns is not at all important. Suppose that I indicate employee number, name and address and designation. It doesn't mean that name and address are having priority over designation. The order is immaterial. What is important in any table is what is indicated as a primary key. Employee number is very important. Apart from this, whatever columns are there, they don't have any significance when it comes to the ordering of the fields. So you should never get confused by the ordering of the fields. It is up to the convenience of the programmer whether he indicates a name or designation, whatever is in the first column or second column or third column. So the only important thing is primary key. The rest are very important whenever it comes to the queries, but not on the ordering feature. Then comes each row represents a single data entity within the entity set. Now let me just go through the employee. The employee is having some features: name, address, employee number, designation. Whenever you have a set of information of an employee, some X is there. He is having some name which is X itself, and then he is having some number, then he will be having some designation, some address. Now this information pertaining to one employee will be coming in a row. So each row is nothing but it is a set of information associated with each and every attribute of that particular object. So each row will be representing one particular object of your entity set. Now each column is again different. Whenever you speak of a column, the column is nothing but it is common information for all the employees. Common information in the sense that the information may be different, but at the same time the attribute is same. For example, the list of all employee numbers, they form a column. The list of all employee names form a column. So though the names are different, the attribute associated with each and every name is same. The width of the data field is also same. So whenever you are interested in finding out only the names of employees, then you will be running a query on a column. Suppose that you want to find out information pertaining to an employee on all the fields, then you will be running a query on the primary key like employee number, which will be fetching the entire information of that particular row and will be displaying. So these are the properties of a relation or table. Now just go through this relational data model. Here we have a table. The most important thing is I can use the word table or relation. Either of the words will mean the same. So here I have a table containing employee number, name, date of birth, address, and then joining date. There were some technical words. The employee number is described as a primary key. The reason for describing employee number as a primary key is that it is unique. Since it is different for each employee, we have termed employee number as a primary key. Then comes name. There might be two employees having the same name, so there is no way for us to term it as a primary key or even as any other key. Date of birth, address, joining date, all the fields are, none of the fields can be termed as primary key or any other key because more than one employee can have this information similarly. At the same time, each and every set of attributes, like the first employee is there, Ram Kumar, his employee number is 1011. Then his date of birth, address, joining date are there. All these are called records. So there are three records in the figure. The three records are corresponding to Ram Kumar, Shamya Dev and Dilip Singh. This word record is also synonym for word called tuple. So whenever you encounter word relation, it is meaning table. Whenever you encounter word attribute, it is corresponding to a field. Whenever you are encountering a word like tuple, it is corresponding to a record. So basically it depends on the particular terminology used by any person or any textbook or any software, what words they are using. But you should always think that these all are synonyms and formulate the suitable meaning. Now let us see the important terms in a relational database management system. They are relational algebra, table or relation, record or tuple. Relational algebra is nothing but it is the mathematical correspondence between a relational database management system and the mathematics. Only whenever you can write a query using relational algebra that you can also design a query corresponding to a particular RDBMS. Suppose that you want to design a query in Oracle. It means that you must have already or you must be able to design the same query using the relational algebra. Relational algebra is the mathematical foundation for the relational database management systems. You have another thing called relational calculus. All these are basic foundations. They are just like pillars of RDBMS. First of all, you should study them to write proper queries. Sometimes there might be a query which is taking a lot of time to be executed by the compiler. The same information can be obtained by writing a query which can be executed in the reduced time. Here comes optimization of queries. So rather than RDBMS optimizing your query, you should always try your best to write queries in such a way that it is executed in minimal time. Executing in minimal time is possible only when you are extracting minimal information from the tables and giving the result without getting the data that is not going to be used in answering the query. All these things will become possible whenever you are having grip over relational algebra and relational calculus. The second is table or relation. The third is record or tuple. These are the most important terms in the relational database management systems. The other important terms are domain, cardinality, degree, value, null value. I will be describing each of these terms. What is domain? Domain is nothing but all the possible values for any field. Suppose that I have described employee number as an integer. It means that all integers they form the domain for that particular field. Suppose that I have described some field of a character type. It means that all the characters will be forming a domain for that particular field. Cardinality. Cardinality means the number, the cardinality of your table. Cardinality of the table means that how many records are there in the table. Cardinality is nothing but it is the number of items which are present. Whenever we are speaking about number of items, the items must be unique. So it is only possible for RDBMS systems to have cardinality because you are having a primary key in each of your tables. The next one is degree. The fourth one is value and the fifth one is null value. Among all the three, the most important one is null value. Whenever you are having a field described as a primary key, it cannot take an empty value. So you should always have some data for the primary key. Whenever you are having a primary key, you will be describing the property of its primary key as a primary key. Apart from that, you will also be indicating that it is a not null attribute. Not null means it can never take an empty value. It means that whenever you enter information into your table, there is no way for you to skip the information related to that particular field. Without entering the information for that particular field, there is no way for you to store the data of that table into your database management system. So null value is a very important word and you will be encountering it in each and every RDBMS whenever you are creating tables particularly. Once the most important point is you cannot make a not null value as a null value so easily without doing proper analysis, because basically on the primary key most of the queries will be designed. So whenever you are allowing that particular field to be empty, there might be a problem whenever you run the queries. So you have to decide whether a field has to be not null or null during your design itself and try your best to not to change this particular attribute of any field. So the next one is you have some more important terms. They are logical data, physical data, schema, subschema and data dictionary. Let me go through each of these terms. Logical data. It is the logical data presentation of data as conceived by the programmer or user. Physical data. Contrary to the logical data, this refers to the way data is actually recorded on the storage medium. Schema. It is an overall chart of all the data item types and record types stored in a database. Then comes subschema, a derivative of schema but for the data item types and record types meant for use of a particular user or application. Data dictionary holds detailed information of different structures and data types, relationships, user privileges, access rights, performance, etc. So here you have logical data, physical data, schema, subschema and data dictionary. Among all these things, the most important are logical data, physical data and data dictionary. Data dictionary will be holding all the data about the data. It means that whenever you create a table, you are having some fields. This particular data dictionary will be containing the details of all these fields, that this particular field is created by so user at so and so time and so machine. So it is very much used whenever someone is doing log analysis. Then comes logical data and physical data. Logical data representation is nothing but what the programmer is viewing before thinking about the RDBMS he has to use. So whenever you are designing something, maybe you did not yet decide whether you have to use Oracle or Informix or Microsoft Access or Sybase, but then you will be having a vision like what the situation should be, how the tables are going to look alike. So whenever you have this particular representation in your mind, it is nothing but it is the logical representation. After you map it onto the tables, it will become a physical representation. So logical data representation, physical data representation and data dictionary, all these three are very important. Then you have relational operators. They are restrict, project, join, divide, union, intersect, difference and product. These are the operators that you will be using it whenever you are designing queries. Basically, whenever someone is working on an RDBMS software, he will be knowing the correct terms that have to be used whenever he is giving a query. But from the user point of view, you should never expect that a user is having knowledge of Oracle whenever he is using a Oracle package. The design should be in such a way that user is totally invisible of the background technology. So here in this, the relational operators might be restrict, join, etc., but at the same time only the programmer will be using them, but not the user. So in this session I have spoke about the relational database management systems, forms, reports and macros. We need to still speak about the query languages and the normalization theory. So I thank all of you for attending the session. In case of any doubt, I request you to give an email to me and I will be very glad to answer them. And in the next session, we will be looking to the normalization theory and query languages. Thank you.